Hello, so in this video we're going to start right at the very beginning of the course. We are going to be looking at algebra, okay? Now you've probably heard of algebra, but I just want to really make sure that you fully understand all the notions associated with it, the notations and the concepts, because it is something that we will be using a lot during this course, okay? So let's actually make a start and actually let's answer the question. What is algebra, okay? Well, there's a couple of ways of looking at it, okay? Number one, you can say that algebra is the maths of unknowns. Okay, so what that literally means is that if you do not know the value of something at the moment, okay, it means that you can still work with it. So if you use algebra, it means that you can still work with it even though you don't know the value of it, okay? And you can still use the laws of numbers and arithmetic, which you're familiar with, and then hopefully you'll be able to find the value of it. And even if you can't, it might describe a pattern which associates the variables or the unknowns together, okay? The other way of looking at algebra is it is the maths of patterns, okay? So we can basically use this concept of algebra to be able to understand the patterns which we see around us, okay? So let me give you an example, okay? Let me suppose, let me just ask you this. What is 2 times 0, okay? Well, you're sitting there and you're thinking, 2 times 0, I think that's 0, okay? And you can stick in a calculator if you're not sure, right? What about if I ask you 3 times 0, okay? Well, you sit there and you go, 3 times 0, that's 0, right? Can even stick a negative number in there, let's say -7. If we multiply that by 0, what do we get? I think that's 0. So hopefully you're noticing a pattern, and this happens a lot in maths. At the end of the day, the heart of mathematics is all about looking for patterns and trying to understand those patterns that exist in the world around us, and then we try and describe them, and that's where mathematics comes in. So here we've noticed, hopefully, that any number, when you multiply by 0, will always result in 0. So I can use algebra to describe this concept. If I take a number, let me give it a name, let me call it A, and if I multiply it with 0, that gives me 0, okay? And I can say where A is any number. Okay, so A is any number, all right? So basically here I've noticed a pattern. I've realized any number times 0 is 0. Therefore, I've generalized this using algebra. Now you notice that with algebra, we tend to use letters to represent the unknowns or the things which we want to generalize. Now we let the letters, we give them a special name. We call them either a variable or a pronumeral. All right. So we call it either a variable or a pronumeral. So a variable, well, the clue's kind of in the name. It means it varies. It's a value that can change, okay? So if you look at this example here, right, this is a variable, A is a variable, because it's a value that can change. I'm basically saying A can be any number. It can change its value, okay? But the point is, when you multiply that value by 0, you'll still always get 0. Pronumeral, we tend not to call it pronumerals in this course, more likely to call it variable, but they can be called pronumeral as well. A pronumeral basically means for a number. So pro means for, numeral means number, okay? So we're basically letting this letter mean a number. So it's for a number, right? Now, let me just show you another abbreviation which we could do. Okay, let's just notice a pattern in the real world. Okay, so let's look around the room which you're currently in. Okay, and what you could say is that the number of eyes in this room will be 2 times the number of people. So it'll be 2 times the number of people. Okay, so the number of eyes in the room are 2 times the number of people. Now the thing is here, this is true, okay? The number of eyes should be twice the number of people because every person has 2 eyes, right? But it looks quite long and cumbersome to write out. So here I can introduce a variable to represent this. So instead of writing eyes all the time and people all the time, I can just let a single letter represent that entire word, entire concept, okay? So I'm just going to let E represent eyes, okay? And I'm going to represent people represent a P, okay? So this is where variables and pronumerals come in. Just think, it just represents a number or an unknown value. And we tend to just let a single letter equal that value because it's easier to write. Now in general, a different letter will represent a different value. Okay, so you can see here, for example, the E is a different value to the P. okay? If it was the same value, then we would just let it equal the same letter, okay? So that's a really important concept. The different letters represent different values, and the same values represent same letters, okay? Now, there's a few sort of little notation shortcuts which you need to be aware of with algebra, okay? So the first, if I have 3 times by some value, okay, let's say p, all right? If I have 3 times by some value, well, I don't write it as 3 times p, okay? I just write it as 3p, okay? So for example, if this p represents people, okay, instead of having 3 times people or 3 lots of people, that's what it says on the left-hand side, I would just simply say 3 people, okay? And that makes more sense, okay? I may have more than one letter or may have more than one number. So for example, I could have something like 6 times b times c. So again, I could just take out that multiplication symbol and I would just write that as 6bc. Now you notice that the order of the letters doesn't particularly matter, but just by convention, we tend to write it with the number first, then the letters in alphabetical order. And that will just make it easier later on when we've got lots of letters working all together, okay? So we wouldn't write, for example, CB6, okay? So, because in that case, the letters are in the wrong order, they're not in alphabetical order, and also the numbers come last, okay? Whereas we want the number first. Okay, so just remember, number first, then the letters in alphabetical order, okay? Some other notations, shortcuts, which we could do. If I have, for example, A plus A plus A, okay? Well, hopefully you realise that if I add the same value to itself, then it's just that many times of the value. So in this case, I'm adding A to itself 3 times, so I could write that as 3 lots of A, or 3A, okay? Similar kind of thing with multiplication. If I have b times b times b, I could write that as b cubed. Okay, and if you're familiar with indices and powers, then we will look at that in the next part. Okay. Another thing which I could write, if I have 1 times by, let's say, c. Okay. Well, instead of writing 1 lots of c, you notice I could get rid of that multiplication. That is fine. But actually, in this case, we tend not to write the 1 there. Because if I have 1c, then we just say it's c, okay? Does that make sense? So it's a bit like saying, if I have 1, what begins with c? Let's say, if I say have 1 carrot, I would just say I have a carrot, right? I just leave the c on its own, okay? So yeah, these are the kind of main shortcuts which you need to be aware of with algebra, okay? These are the main shortcuts, okay? But hopefully this is a bit of revision. Now, let's actually move on to doing something with algebra, all right? So we're going to move on to simplifying. Now, I hate the word simplify in maths because it actually is quite an ambiguous term. Simplify just simply means make something simpler. Well, the thing is, it depends who you ask as to whether it's simple or not. Because some people may look at something and go, yeah, that's simple. And other people might go, no, that's not simple, okay? And I hate the word simplify for that very reason. But the more practice you do with these style of questions, the more familiar you'll become and you go, right, okay, they're asking me to simplify, but I know what they're after. I know the form of the final answer. So let me give you an example. Let's suppose I have 4x plus 6x minus x, okay? And I ask you to simplify this. Now, the reason why this is not simplified at the moment, this isn't in its simplest form at the moment, is because you've got x's everywhere, okay? Now, by the way, the bits in between the plus and the minus, we call a term. So here we've got a term, the 4x. Here's another term, the 6x, and here's another term, the x, okay? So these are all called terms. So the bits in between the pluses and minuses are called terms. Now, the sign of that term, so whether it's positive or negative, is always given by the sign which precedes it. So, for example, if you look at this last term here, this last term will be negative because there's a negative in front of it. Okay, there's a minus symbol. This 6x will be positive because there's a plus in front of it. And this 4x will also be positive. It's just we haven't bothered to write it. Okay, so there is a plus there just kind of hiding. Okay, so if you don't see a sign in front of the term, assume it is positive. Okay. So at the moment, we have got an x in every single term, Okay, so let's suppose, for example, 4x plus 6x minus x. Let's x actually represent something. Let's suppose x is eggs. Okay, I know it's a bit of a, it doesn't begin with x, but it sounds like it, right? So let's suppose we have 4 eggs, and we want to add another 6 eggs, and then we want to take away an egg. Okay, well in total, we would have 4 eggs plus 6 eggs, that makes 10 eggs. Take away another egg, that leaves us with 9 eggs, or 9x, okay? So basically, this is called like terms. The reason why they are like is because even though the numbers in each of the terms are different, they all have the same variable or pronumeral in them, okay? So because they all have x in them and nothing else, it means that they are alike, okay? They're like terms. So it means that I can collect them just simply by taking 4 plus 6, take away 1, that gives me 9, and then I've still got the x left over. Let me show you with another example. Let's show you with 3xy plus 4x plus 6y minus 2xy. Okay, now first of all, let's find the like terms. Okay, so let's first of all identify the terms. Well, there's a term there, the 3xy, another term there, there's a 4x, another term there, 6y, and another term there, 2xy. Okay, now I want to find the terms which are alike. Okay, now don't fall into the trap here. You notice this term and this term has both got an x in. These are not like terms though. The reason being is because the first term, okay, this term here, has an x and a y in, whereas this term only has an x in. So therefore they are not like terms, okay? They have to have both an x and a y in. So you notice the first term has an x and a y in, and the last term has an x and a y in. Therefore, these are like terms. Now, if I look at the other two, well, this term has an x in, but this term has a y in. Therefore, these are not like terms either, okay? So actually, I have 3 sets of like terms. I have terms with x and y in, I have terms with x in, and I have terms with y in, and that's it. So I've got 3. So if I want to collect together like terms, what I need to do is look at the like terms. So this one here is like, this one here is like. So if I have three of something and I take away 2 of something, I'm just left with 1 of that thing. So 1 of that thing is just the xy. Okay, I just put the xy back in there now. And you notice that I can't do anything with the x. There's no other like terms there. So I'm just going to keep that as 4x. Now notice I need to keep the sign of that term there, so it's positive. And also the 6y, that is also positive. There's no other like terms, so I'm going to write that as plus 6y. Okay, so this would be it fully simplified. Now, let's answer this question then. So in these types of questions, what do we mean by simplify? Well, in this case, what they're literally asking us to do is to write it with fewer terms. Okay, so you notice that in the first question, we started off with 3 terms, the 4x, the 6x, and the negative x, okay? And then we ended up with 1 term. That's simpler, okay? Also, same is true here. Same is true here. We have 3xy plus 4x plus 6y minus 2xy. That's 4 terms, and we ended up on the right-hand side with 3 terms. Okay, so that's what we mean by simplify, okay? Let me give you another example, okay? So let me give you this one. Let's suppose we have 12x squared minus 2x minus x squared plus 6y squared minus 9x minus 10y squared. Okay, now I'm going to write the equals on the next line because we're running out of space slightly. So let's have a look at this. Okay, let's first of all go through and find the like terms. So let's look at the first one. We've got 12x squared. Now a like term will be anything else which has only an x squared in. So the next term doesn't work, because that's just an x, but the next term does work. I've got x squared there. Then let's have a look. There's no other terms with x squared in. Okay, so let's do the x squared bits first. Well, okay, I have 12x squared, then I take away an x squared. So if I have 12 of something and I take away something, then I'm just going to be left with 11 of that thing. Okay, let's have a look at the next terms. Let's have a look at the negative 2x. All right, now is there any other terms with an x in? Yes, there are. There's over here at the negative 9x. So be sure to include that negative because both of those terms are negative, right? So I've got negative 2x, and then I'm going to take away 9x. Well, that's going to leave me with negative 11x. All right, fantastic. Now let's have a look at the last terms, which we haven't dealt with. Well, okay, the next term we've got is a 6y squared. So that's going to be a term with y squared in. Well, let's have a look. Are there any other terms with y squared in? Yes, there are. The last term. So we've got 6y squared, take away 10y squared. That's 6 of something, take away 10 of something. That's going to leave us with negative 4 of that thing. So it's going to be negative 4y squared. So again, what do we mean by simplify here? Well, it means write this thing with fewer terms. So we started off with, well, let's count, 1, 2, 3, 4, 5, 6 terms, and we ended up with 3 terms at the end. Okay, so that's what we mean by simplify. Okay, now it's important to distinguish a little bit of an idea here. Okay, if I write you down something like this, 3x plus y. Okay, we would call this an expression. If I wrote down something like this, so if I wrote down 3x plus y equals 12, we would call this an equation. Okay, so it's important to be aware of the difference. Okay, so an expression doesn't have an equals in. Okay, it's just simply a collection of terms. Okay, so in this case we have 2 terms, we've got a 3x, we've got a y, and we're adding those 2 terms together. It's just an expression. Okay, whereas this term has an equals in, and the clue is kind of in the name. If you look at the word equation, it means to equate. It's got the word equal in. Okay, so there's the equals there. So just be aware, if you're talking about the difference between an expression and an equation, simply one has got an equals in, one hasn't got an equals in. Now, there is one other type of sort of way of writing algebraic things, which is an identity. So if I write, for example, sine squared x plus cos squared x is identical to 1. Now you notice in this case we're using 3 lines instead of 2 for the equals. We would call this an identity. Now I'm not going to go into this too much, but effectively an identity and an equation, they're very similar. Okay, so you can almost imagine that this thing here, these 3 lines, can be treated exactly the same way as these 2 lines. Okay, however, it does mean something a little bit more. Okay, so if you look here, for example, if I change that y to be something like 4, okay, so to something like 4, then basically what this thing means, the equation, is that there's only one value of x which would work in this equation, or maybe only 2 or only 3. Okay, so there's only particular values of x which would work in here. Whereas an identity, so when we've got these 3 lines, it basically means I can stick any value of x in here I like, and it will always hold true. So the difference between an equation and an identity. An equation is something where only one value or 2 values or 3 values, only a finite set of values will hold in this equation. So only in this case, it's going to be 8/3. Okay, so 8/3 is the only value of x which would work in this equation, or 2 2/3 if you prefer. Okay, whereas in this bottom thing, the identity, okay, any value of x which I stick in this equation will work. So the difference between the two is subtle. It's not necessarily important that you have to know the difference, but I thought I'd point it out here. But it is important to understand the difference between an expression and an equation / identity. All right, okay, fine. Now, what else can we do with algebra? Okay, we're just getting our algebraic skills on the go here. Well, I could ask you to do something called expansion. Okay, so expansion. So if I give you something like this, let's try 5x times by x minus 4. Okay, so here I've got an expression because it doesn't have an equals in. Okay, so 5x is brackets x minus 4. Now, just be aware, these brackets mean that you're grouping stuff together. Now, they're not actually called brackets, they're called parentheses, but I don't mind whether you call them brackets or parentheses. I tend to call them brackets because it's fewer syllables, right? But basically what's happening here, just like right at the very beginning, I said we don't need to write the times in. What's actually happening between this x and this bracket is a multiplication, okay? It's a multiplication. Now, what I'm going to use here is something called the distributive law. What that basically means is that I can distribute this 5x, this term here, the 5x, over every single term inside the brackets. Okay, so you notice I've got an x term and I've got a negative 4 term. So if I write this, it will basically be, well, let's do it in stages. Let's do 5x multiplied by x. Okay, so I'm just going to write that down. So 5x multiplied by x. Okay, and then secondly, I'm going to do 5x multiplied by negative 4. Okay, so I'm going to do 5x, so positive 5x multiplied by negative 4. Okay, so I'm literally just writing that out. So 5x times x, that's my first bit over here. And then positive 5x take away times by negative 4. Okay, the reason why it's positive 5x is because just remember there is a positive hiding out the front there. I just haven't bothered to write it in. Okay, so now let's see if we can simplify this down. Well, okay, 5x times x. Just remember that means 5 times x times x. So in other words, I've got 5 times by x times by x. Well, the x times x just makes x squared. So in total, I will have 5x squared here. Okay. Now, if you look at the next term, well, I've got positive 5 times by negative 4. Let's do the numbers first. Positive 5 times by negative 4. That makes 20, but because I've got positive times a negative, it's going to be negative 20. Okay. So I have plus negative 20, or just take away 20, and then I've just got an x there. Okay, so this will be it fully expanded. So what do I mean by expand? It simply means remove the brackets. Okay. So expand means makes bigger. In this case, get rid of any factors. Just simply write it out without any brackets at all. Okay. Now you notice I did it kind of intuitively, but it's worth pointing out here. Have a look here. Okay. So have a look here, where I've got x times by x. You notice the way that I write my x in algebra, so my letter x, and my multiplication is different. If I'm going to write a letter x, I tend to write it quite curly. Okay, so I tend to write it like this. And if I write a multiplication, I tend to write it as a cross like this. And that just avoids to make any kind of confusion. Now, if you're not kind of convinced by that, if you're kind of still looking at this bit and you're still going, I'm not sure it actually makes that much of a difference, then you could, if you wanted to, replace that with a multiplication sign. So just with a dot. Okay, so there's two ways of writing multiplication. Well, technically 3 in algebra. You could either not bother writing anything at all, okay, or you could write a times symbol in, or if you prefer, you could write this dot. Okay, so that is the same as a dot. Okay, so it's worth being aware of that. All right. All right, fine, fantastic. So expand means to get rid of the brackets. Let's have a go at another example. Okay, let's have a go at something like this. 3x times by x plus 5. Now notice I'm just using x quite a lot. X is a commonly used pronumeral or variable in algebra, but it honestly doesn't matter as long as the letters remain the same. Okay, so let's have a look at this. So, okay, I need to take the 3x and it needs to visit the x. So I'll have 3x times x, which hopefully you can do in your head, will be 3x squared. Okay, and then I've got positive 3x times by positive 5. That is going to be positive 15x. Okay, so you notice when you're collecting together symbols like that, so I've got 3x times 5, I just simply multiply the numbers together, then I multiply the letters. Okay, so I've got 3 times 5, that makes 15, then I've just got the x. All right. Now, if you prefer, what you can think of this as is almost like going to visit somebody's house. Okay, so let's suppose 3x is a person, so I'm going to draw a person here. Okay, and they're going to visit somebody's house. And there's a couple living in this house, okay? And the couple which are living in this house are inside the brackets, okay? So you've got Mr. X, okay, you've got Mr. X, and you've got Mrs. 5, all right? Now, if you go to visit somebody's house, it's really rude if you don't visit everybody, okay? So the 3x has got to visit both the x, so the 3x has got to visit both the x, and the 3x has got to visit the 5. Okay, and of course you've got to plus those together because they're both positive. Okay, so remember the sign which goes in between these two usually is the same as the sign inside the bracket, but of course you just have to be aware if there's any signs out the front. All right, so that might be quite a nice analogy to use. All right, let's move on then. Let's have a look at this example. And just to show you that you don't need to use x all the time, let me write down y plus 4 times by y plus 5. Okay, now this is a little bit more tricky, but it's not if you use my house analogy. It's okay, let's suppose the people in my first bracket, so let's say Mrs. Y and Mrs. 4 are going to visit So in their house, they're going to visit these two. So Mrs. Y, another Mrs. Y, maybe their twin sister, and Mrs. 5. All right, okay. Now, obviously, you've got to meet up with everybody. So the Y, so Mrs. Y over here, has got to meet up with everybody in the house, okay. So the Y has got to meet up with Mrs. Y, okay. The Y has also got to meet up with Mrs. 5, okay. So just be aware you've got to add those two things together because it's a positive Y times by positive 5, okay. Then also the same is true for the 4. Okay, so 4 is positive and he's meeting up with positive Y, so it'll be plus y, 4 times by Y. Okay, and then again, Mrs. 4, which is positive, is going to meet up with Mrs. 5, which is also positive, so it'll be another positive there, and it'll be 4 times 5. Okay, now actually, you notice here that I've written 4 times 5 with the dot. Okay, that looks wrong, okay, because it looks like 4.5. So actually, if you're combining together two numbers, write a times. Okay, it's always better to write a times. It's fine to write a dot if you're combining letters and numbers, or letters and letters, but if you want to combine together two numbers, always write a multiplication. Okay, so if I'm going to do this, well, y times y, we've already done that in our abbreviations at the start, that should be y squared. Then I have plus, well, y times 5, you'd never write it that way round, you always write the numbers first, then the letters, so it'll be 5y. Then again, 4y, you don't have to write the 4 times y, do you? You could just write the 4y like that. And then 4 times 5 is 20. Now have a look at this. Is there any simplification which I can make? Well, look, I've got two like terms in the middle. I've got a 5y and a 4y. So if I collect together those like terms, I have y squared plus 9y plus 20. Okay? So if you want to use my house analogy, okay, that's how to expand this bracket out. If you didn't want to use my house analogy, let me show you how I could do it. So y plus 4 times by y plus 5. It's basically the same thing, but using arrows instead. Okay, so effectively the y has got to meet up with everything in the second bracket. And what I mean by meet up is just simply multiply. Okay, so the y has got to be multiplied by the y, that's going to give me y squared, and the y has got to be multiplied by the positive 5, that's going to give me positive 5y. Okay, if I do the same for the 4, again, it's got to meet up with everything in the second bracket. So the 4 has got to meet up with the y, so that's going to give me 4y. And the 4 has got to meet up with the 5. They're both positive, so it'll be positive 20. Okay, and again, I can simplify the two terms in the middle to make 9y. Okay, so either way you want to do it. If you want to visualize the house analogy just whilst you're getting started, and then just make sure that everybody meets up with everybody else. Obviously, two couples don't have to meet up together. So you notice these two couples here, so I should sort of point this out. These two couples here don't have to meet up because they're already together, and these two couples don't have to meet up, so they're already together. So you don't need to multiply those two, it's just simply new couples have to meet up with the two other people in the couple. Or if you prefer to do this way, that's fine as well. Let me show you with another example. Okay, so this is question 4. So let me show you with this example here. Okay, let's try y times by y minus 1 times by y minus 2. Now, how are we going to deal with something like this? Okay, so I'm going to use my arrows. So first things first, I'm just going to focus on this part. Okay, I'm just going to focus on this part here. So we have y minus 1 times by y minus 2. Reason being, that's exactly the same as what I was doing in the last question. So let's have a look at this. Well, okay, the y in the first bracket has to meet up with everything in the second bracket. So we've got y times y, that makes y squared, and we've got positive y times by negative 2. That's going to give me negative 2y. So always think, is it positive, 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 negative, negative, positive, or negative, negative? Then that will tell you the sign which goes in front of the term. Okay? Then we've also got the negative 1 in the first bracket has to meet up with everything in the second bracket. So in other words, we've got negative 1 multiplied by y, or negative 1 times by y is negative 1y, which I can just write as negative y. Okay? Then we've also got negative 1 times by negative 2. That's going to give me positive 2. And then finally, all that's left to do is to simplify. So we have y squared. You notice the negative 2y take away y. That's going to give me negative 3y. And I've got the plus 2. All right. So that's basically what I can replace my red thing in up here. So in other words, I have y times by, and then I just replace my red with this. So that's my expanded thing. So y squared minus 3y plus 2. All right. Now all that's left to do is to make sure that the y outside the bracket meets up with everything inside the bracket. Okay, so let's have a look at this. Well, we have y times by y squared, that's going to give me y cubed. Then we have y times by negative 3y, that's going to give me negative 3y squared. And then y times by positive 2, that's going to give me positive 2y. So in other words, my final thing expanded will be this thing down here. You notice how I do this? Only expand two things together at the same time. Okay, and then if necessary, you can go back and add anything else in later on. Okay, so as a one final example, let's try this thing. So let's change this to z plus 7 times by z minus 3 times by z plus 5. You notice that I write my z's like this. Reason being is if I write them like this, it looks very much like a 2. Okay, so if I want to write 2z, for example, without using that, it kind of looks like 2, 2, right? Whereas if I put a line down the middle of my z, it just makes it a little bit easier to view. Okay, so something to bear in mind. All right, here, all I'm going to do is just multiply two brackets together at a time. So let's just choose two. I'm just going to choose the last two. All right, I'm just going to choose those last two. So let's just multiply these things out. Let's see if we can do it quickly. So we have z minus 3 times by z plus 5. All right, so in other words, I get z times z and z times positive 5. That's going to be z squared plus 5z. Then I've got negative 3 meeting up with everything in the second bracket. So negative 3 times z is negative 3z. And negative 3 times positive 5, that makes negative 15. Then just finally simplify, collect together these like terms in the middle. So we've got z squared. And then we've got positive 5z, take away 3z, that's positive 2z. And then minus 15. So in other words, I can write this thing up here as z plus 7. Haven't changed that first bracket. But the second two brackets, the one I've highlighted in red, can be just rewritten as this. So in other words, we've got z squared plus 2z minus 15. Just please make sure you put all that in a bracket. All right. And then again, all I'm going to do is make sure everything in the first bracket meets up with everything in the second bracket. So let's do the z meeting up with everything in the second bracket first. So z times z makes z cubed. Z times 2z makes positive 2z squared. And then z times by negative 15, that makes negative 15z. Okay, then if I do the same with the positive 7 in the first bracket, making sure it meets up with everything in the second bracket. So in other words, I get positive 7 times by z squared. That's going to give me positive 7z squared. Then if I have positive 7 times by positive 2z, that's going to be positive 14z. And then if I have positive 7 times by negative 15, well, okay, that's going to be, we'll break it up. Positive 7 times by 10 is 70. Positive 7 times by 5 is going to be 35. So that means it's going to be 105, but it's a positive times a negative. That means it's negative 105. All right. Now all I'm going to do is collect together the like terms. So you notice there's no other term in here which begins with a z cubed. Therefore, or has a z cubed in. Therefore, there's just going to be a z cubed. Okay. Now, if I look at the z squared terms, well, there's a z squared term there, and there's a 7z squared there. So therefore, in total, I'll have 9z squared. Now, let's have a look at the z's. Well, I've got negative 15z there, and I've got positive 14z there. That's going to give me negative 1z, or just negative z. And then finally, all that's left is that negative 105. So I'm just going to write negative 105 there. So that would be the final simplified answer. Okay, so you notice, just do it systematically. Make sure everything in the first bracket meets up with everything in the second bracket, and you'll be okay. Okay, now let's look at the reverse of expanding. So now let's look at factorizing. So remember, expanding means get rid of the brackets. Okay, factorize means put the brackets back in again. In other words, find a factor. So let me give you something like this. Okay, let me give you something like 3x plus 6. Okay. So here I've got two terms, and I need to look at those two terms. I've got the 3x and I've got the 6. Now let's focus on the numbers first of all. Let's focus on the numbers. So I need to find myself, ignore the x, I need to find myself a number that is a factor of both 3 and 6. Remember, factor means goes into, okay? So find me a number that goes into both 3 and 6. Well, I think 3 works, okay? And you want to try the highest number that goes into both. So I think 3 works. So I'm going to put a 3 out the front, okay? Then basically what I'm going to do is almost write this with my brackets in again. So I'm going to put my brackets here, and I'm going to keep my plus the same there. Now the plus will nearly always stay the same. So the symbol in the middle here will nearly always stay the same here. There are some instances where it will change, but for the moment, let's just keep it as a plus, okay? Now what I want to do is have a look at the letters. Well, have a look. There's a letter, there's an X in the first term, so there's a letter in the first term, but there's no letter in the second term, which means that I know that there's no factors with the letters that I can remove. All right? So in other words, the 3 is the only factor of both of these terms. It's the only thing that goes into both of these terms. Now all I need to do is just expand what I've got on the right-hand side and try and get back to what I've got on the left-hand side. Let's have a look. So I know that 3 multiplied by something has got to give me my first term, has got to give me 3x. Okay, well 3 times by what gives me 3x? It's got to be an x, all right? Then if I do the second term, so if I do 3 times by my second thing in my bracket, I know that's got to give me 6. So 3 times what gives me 6? It's got to be 2. So that would be it fully factorised. Okay, so 3x plus 6 can be written as 3 lots of x plus 2. Let's do it with another example. Let's do it with 15x minus 10. Okay, so let's look at the numbers first of all. Well, actually, first of all, I'm going to put my brackets in here, and I notice the symbol in the middle is a negative, so I'm going to put a negative there as well. Okay. All right. Now let's have a look at our numbers. What numbers are common to both 15 and 10? Well, have a look. Isn't it 5? Okay, that's the number which is in common to both, so I'm going to put 5 out the front. Now have a look at my letters. Are there any letters which are in common to both terms? Well, there's only an x in the first term and there's no letters in the second term, so I know that there's no letters in common. Okay, now I'm going to expand this out. So I know 5 multiplied by something that goes here has got to give me 15x. Well, have a think. 5 times what gives me 15x? Well, 5 times 3 gives me 15, and then that times by x is going to give me 15x. So 5 times by 3x will give me 15x. Okay? Now if I do the same with the second term, 5 times what gives me 10. Okay, remember I've already got the negative here, so I don't need to worry about the negative 10. So 5 times what gives me 10? Well, I know that that has got to be 2. So 5 times 2 gives me 10. All right, let me do it with another example. Let's try, for example, 7a squared minus a. Well, first things first, I'm going to set my brackets up. I'm going to keep the symbol the same in the middle, so in this case a minus, okay? And let's have a look. Okay, now I'm going to first of all look at the numbers, same as before. Well, are there any numbers which are in common to 7? And just remember there is a 1 hiding there in front of the a. Okay, so are there any numbers which are in common to both 7 and 1? Well, 1 is, but we don't really treat 1 as a number which we can stick out there, okay, because we don't need to bother with it, because 1 times anything is just itself. So in answer to this, there's no numbers which are in common to both 7 and 1. Okay, so I don't need to worry about the numbers. But now let's have a look at the letters. Well, I've got an a squared in the first term and an a in the second term. Are there any numbers which are in common to both? Yes, there are. Okay, there's an a which is in common to both. So I'm going to stick an a out the front of the bracket because there's an a hiding in the a squared and there's an a obviously in the second term. Okay, so now I can basically expand this. So a times by something has got to give me 7a squared. Well, a times by 7a is going to give me 7a squared, right? So I know a 7a has got to go there. Now if I take a multiplied by the second thing, that's got to give me a. Well, a times what gives me a? It's just going to be 1. So that would be it fully factorised. Let's try with this example here. Let's try 6ab plus 3a. Let's have a look at this. So first of all, I'm going to set up my brackets. So I'm going to put my brackets in. I'm going to keep the symbol the same in the middle. Okay, I'm going to keep it as a positive. All right, now let's ask myself the question, are there any numbers which are in common to both of these things? So I've got a 6ab and I've got a 3a. So I've got 6 and a 3. Are there any numbers which are in common? Yeah, there's 3, right? So I'm going to stick a 3 out the front here. Now I'm going to look at the letters. Are there any letters which are in common to both? Well, I've got an a in both terms, which means that I can stick an a out the front here. And then the b, well, there's only a b in the first term, there's no b's in the second term. So that's it. That is my factor. That's the thing which I can factorise from both terms. So now all that's left to do is basically expand this to make sure I get back to the thing on the left. So 3a multiplied by the thing that goes in the first bracket has got to give me 6ab. Well, 3 times by 2 is going to give me 6. I've already got the a there, so I don't need to worry about multiplying a by anything, so I don't need to put another a there. But have a look, I also need the b. So if I multiply 6a multiplied by 2b, that's going to give me 6a times b, 6ab. That's what I want. All right. Now if I have a look at the second term, so 3a multiplied by something that goes there has got to give me 3a. Well, in this case, it's just going to be 1. Okay, so that would be it fully factorised. Have a go at this example. So let's try 4ab squared minus 6a squared b. Okay, let's have a look at this one. All right, so basically I need to look at my numbers first of all. Well, first of all, actually, I need to set up my brackets, don't I? And let's keep the negative the same there. All right, so let's have a look. Okay, let's have a look at my numbers. So are there any numbers in common to both 4 and 6? Well, I think 2. 2 is in common to both 4 and 6, so I'll stick a 2 out the front there. Then I look at my letters, and I look at each letter individually. So have a look. Let's have a look at my A first of all. Well, there's an A hiding in both terms, because there's an A in the first term, and there's an A squared in the second term, which means that I can pull an A out. Then if I have a look at the B's, well, there's a B squared in the first term, a B in the second term, I can pull a B out the front there. So that there is my factor, 2AB, okay? So what I'm going to do now is basically expand it to make sure I get the same thing back. So I've got 2AB multiplied by the thing in the first position has got to give me 4AB squared. Break it down. 2 times what gives me 4? Well, that's going to be 2. A times what is going to give me A? Well, there's 1, so I don't need to worry about it. And then B times what is going to give me B squared? Well, I need another B. So just simply break it down, number, then letters. I need to do them each individually. All right, now let's do the second term. So 2AB multiplied by something that goes here has got to give me 6A squared B. Well, 2 multiplied by 3 is going to give me 6. A multiplied by A is going to give me A squared. And B multiplied by 1 is going to give me B. So I don't need to worry about writing that there. So in other words, the thing that goes in the second term is a 3A. Okay? All right. Now let's have a go at this one. So similar kind of principle. It's just got 3 terms instead of 2. So let's try 15a cubed b squared c plus 5a squared b cubed c to the power 4 plus 30 a to the power 4 b to the power 5 c to the power of 6. Okay, so don't get put off. It's the same principle as before. So first things first, I need to set up my bracket. So in this case, I'm going to set up a big bracket because there's 3 terms, and I'm going to separate them with pluses because they're both pluses here and here, right? All right, okay, let's have a look at this then. So let's first of all focus on the numbers. So I've got 15, 5, and 30. What numbers are in common to all of those 3 things? 5. Yeah, you happy? So I can stick a 5 out the front there, okay? Now let's have a look at the A's. So break them down individually. Now let's have a look at the A's. So I've got an A to the power 3, an A to the power 2, and an A to the power 4. What is common to every single one of those things? Well, basically, what's in common? Well, I've got an A cubed, which means A times A times A. I've got an A squared, which means A times A. Then I've got an A to the power 4, which means A times A times A times A. Okay? So how many A's can I pull out of every single thing? Are you happy I can pull 2? I can pull 2 out of every single thing, so I can pull an A squared out. Because there's 2 A's being multiplied together in every single one of these 3 things. Does that make sense? If I write this out, so A cubed means A times A times A squared means A times A, and A to the power 4 means A times A times A times A. Okay? So how many A's are in every single term? So I want every single term. Okay? Well, are you happy there's 2 A's in the middle, there's 2 A's hiding in there, and there's 2 A's hiding in there, which means that I can pull 2 A's out of every single term. Yeah? So I don't want to write it as 2 A's, I want to write it as A squared. Does that make sense? Okay. Let's do it the same with the B, see if it makes sense. So let's actually write it out, okay? So the B squared, well, I've got B times B here. The B cubed, well, I've got B times B times B here. And I've got B to the power 5, that's B times B times B times B times B. So I'm looking for the most number of B's that I can pull out of every single thing. We'll have a look. I've got 2 B's there. There's still 2 B's hiding in there, and there's still 2 B's hiding in there as well, which means that I can pull out a B squared from every single term. All right, now let's have a look at the C's. Let's have a look at the C's. So in the first, I have 1 C, so I've just got C there. Here I've got C to the power 4, which means I've got 4 C's multiplied together. And the last one, I've got 6 C's being multiplied together. So C times C times C times C times C times C. Okay, so I basically need to pull out the most number of C's. Well, there's 1 C there, 1 C there, and 1 C there. Now you notice the shortcut which I'm using here, I'm just basically pulling out the lowest power of C in all of these things. Okay, so you notice with the B's, I pulled out the lowest power of B that was in all of the terms. Okay, and the same thing with the A's, the lowest power of A. Okay, so in this case, there's just going to be a C which is hiding in the front. Now it's just a case of expanding it. Okay, so actually this is the easiest bit now. It's just the expansion part. So let's break it down. So this thing multiplied by the first term has got to give me this. Okay, break it down. 5 times what gives me 15? That's going to be 3. A squared times what is going to give me a cubed? That's going to be another a. B squared times what is going to give me b squared? Well, that's just going to be 1. And then c times what is going to give me c? Again, that's just going to be 1. So actually the first thing there is just going to be 3a. Let's break it down and do the second thing. So that multiplied by the thing in the second position has got to give me this. Okay, let's break it down again. So 5 times what gives me 5? Just 1, so I'm not going to bother writing it. Then a squared multiplied by what gives me a squared? Again, it's just going to be a 1. So at the moment, if I have to write a 1 there, that's fine. Okay, but let's have a look. B squared multiplied by what gives me b cubed? That's going to be another b, so I'm going to write that in. And then c multiplied by what gives me c to the power 4? That's going to be c cubed. Let's do the last term now. So we've got this multiplied by the thing in the last position has got to give me this. So 5 times what gives me 30? Well, that's going to give me 6. A squared times what is going to give me a to the power 4? That's going to give me a to the power of 2. B squared times what gives me b to the power 5? That's going to be a b cubed. And c times what gives me c to the power 6? That's going to be c to the power of 5. Okay, so there we go. Okay, that would be it fully factorized. Okay, so hopefully that makes sense. Okay, so factorization just means put the brackets in. Expand means get the brackets out. Okay, now there's one other type of simplification that I want to do, and it's fractions. So let's have a go at some of these. Okay, let's have a go at some of these. So let's first of all try a over 4 plus b over 5. Now first things first, let's just remind ourselves with fractions. Okay, if I give you 3/4 plus 2/5. Okay, now the issue is here, if I actually convert this into words, okay, if I said 3/4 plus 2/5. The problem is, if I'm trying to treat this as algebra, it's basically saying if I have like 3 dogs plus 2 cats, I can't combine these two things together. Okay, I've literally got the dogs and the cats, I can't combine them together, they're not like terms. So what I need to do is make them like terms, okay? In other words, I need to change the quarters and the fifths into something which is alike. Now that's okay because I understand equivalent fractions, okay? So I'm looking for a number which both 4 and 5 go into, because the denominator is the thing which I'm looking for. So I basically need to have the same denominator. So can you see a number which both 4 and 5 goes into? Well, the simplest way of doing this is just multiplying 4 and 5 together, and then I'll get a number which both 4 and 5 go into. Okay, so let's have a look. I'm looking for a number which both 4 and 5 go into. That's going to be 20. Okay, so I could rewrite this as these two things over 20. Okay, but then I also need to change the numerator as well because it's equivalent fraction. So what have I done to the first fraction to get a 20 on the denominator? Well, I've taken 4 and I multiplied it by 5, which means I also need to take the numerator and multiply it by 5 as well. So in other words, I get 3 times 5, which is 15. If I do the same with the second fraction, again, 5 to 20, I've multiplied by 4, which means I also need to multiply the 2 by 4 as well. I need to multiply the numerator by 4. So that's going to give me an 8 there. Now what I've got, if I convert this into words, is 15/20 plus 8/20. Well, that's a bit like saying 15 cats plus 8 cats. That's going to leave me with 23 cats. So in other words, this should be 23/20. So as the answer down here is going to be 23/20. Okay, so basically all I've done here is just added together the two things on the numerator and the denominator stays the same. All right, so let's actually use this notion over here with this. So it's the same principle even though there's just unknowns, there's variables or pronumerals in here, the a and the b. Okay, so first things first, I need to make sure I have the same denominator. Well, I've just seen if I have a denominator of a quarter and a denominator of a fifth, I can make a denominator of a 20th. Okay, that's going to be common. All right, then all I need to do is think, right, what have I multiplied that first fraction by to get a 20th on the denominator? Well, I've multiplied by 5. You happy? So if I multiply that a by 5 as well, then I'm going to get 5a. you're going to get 5a. So I've just multiplied numerator and denominator by 5 with the first fraction. Second fraction, what have I multiplied by? Well, I've got from 5 to 20, I've multiplied by 4, which means that I also need to multiply the numerator by 4 as well. So if I take b and multiply it by 4, I get 4b. Now all that's left to do, have a look, I'm kind of at this stage here now. All I need to do now is just add together the numerators and the denominator is going to stay the same. In other words, I know that this is going to be over 20. So if I have the numerators added together, I have 5a plus 4b, that's going to be 5a plus 4b. I can't do anything there. So in other words, this thing fully simplified is 5a plus 4b all divided by 20. Okay, and I've just simply thought about fractions here in order to get this to work. So in this case, when it asks me to simplify, all it's asking me to do is write it as a single fraction. So this is what we mean by simplify in this context. You notice, like I say, as you get more familiar with the types of questions that are being asked here, particularly simplification questions, you'll be like, right, I know what they're asking here. So if I give you something like this then, let's try 5 plus b over 4. Okay, 5 plus b over 4. Let's simplify this. In other words, write it as a single fraction. Okay, so what I need to do first of all is make sure I have the same denominator. Now there's a problem here because this thing here, the 5, is not actually a fraction. Okay, or at least it's not written like a fraction at the moment. So in order to write any number, any integer as a fraction, I can just stick it over 1. Okay, so 5 over 1 simply means 5 divided by 1. Yeah, we met that at the beginning. If you see a fraction, just think divide. So we've got 5 over 1, that could be thought of as 5 divided by 1, so that's now a fraction. Now what I need to do is make sure I have the same denominator. The easiest way of getting the same denominator, remember, is just multiplying these denominators together. So 1 times 4, that means that I'm looking for a denominator of 1 times 4, or just 4. Okay, so both of these things now are over 4. Now just have a think. What have I multiplied this first fraction by to get a denominator of 4? Well, 1 times what gives me 4? I've multiplied by 4, which means I also need to multiply by 4 on the numerator. So 5 times 4 is going to give me 20. If I have a look at the second thing, we'll have a look. What have I multiplied the denominator by to get 4 on the denominator? I've multiplied by 1, which means b times 1 is just going to give me a b here. Now I'm in a position where I can actually just add these two things together. Well, if I add two fractions together with the same denominator, I keep the denominator the same, and I just add the top two. So 20 plus b is just 20 plus b. Okay, so that's it fully simplified. All right, let's have a go at this thing then. This is number 3. Let's try a plus b over 2 minus a over 5. Okay, let's have a go at simplifying this now. So write it as a single fraction. Again, I need the same denominator. So to get the same denominator on each, I multiply these two numbers together. So 2 times 5. So if I multiply the denominators together, 2 times 5 makes me 10. And I get 10 here as well. So what have I done to that first fraction in order to get a 10 on the denominator? Well, I've multiplied by 5, which means I also need to multiply by 5 on the numerator as well. So if I take a plus b, and I need to multiply by 5, notice I'm just going to write that as a bracket, okay? Because I'm basically saying multiply the entirety of a plus b times 5, okay? Now if I have a look at the second fraction, well, what have I multiplied here by to get a 10 on the denominator? Well, I've multiplied 5 by 2. So I also need to multiply by 2 on the numerator. In other words, 2 times a, or just 2a. Now before I go any further, I'm just going to multiply out the numerator. So I've got 5a plus 5b. Okay, I've just simply expanded this thing out, just like we were doing before. So 5a plus 5b. Okay, so 5a plus 5b over 10. Oops. Make sure it's the same colour. Over 10 minus 2a over 10. Now all that's left to do, because I've got the same denominator, is just write this as one single numerator. So 5a plus 5 minus 2a all divided by 10. Okay. So let's have a think. Well, 5a, take away 2a, those are my like terms. That's going to give me 3a. Still got the plus 5, there's no like terms with that. And then plus over 10. So that's it fully simplified. Now let's try something like this. Okay, so this is question 4. Let's try 3 over 2x minus 7 over 5x. So let's have a look at this one then. Okay, so again, I need the same denominator. So in order to get the same denominator, I'm just going to multiply these two denominators together. So 2x times 5x, well 2 times 5 is 10. And the x times the x is going to make my x squared. Okay, and I need the same thing on the denominator of both fractions. So 10x squared is my denominator. Okay. Now, what have I multiplied by to get 10x squared on the denominator of the first fraction? Well, you've just seen it. I've just multiplied by 5x, right? 2x to 10x squared, I've multiplied by 5x. So I also need to multiply the numerator by 5x as well. So 3 times 5x, that's going to give me 15x. What have I multiplied by on the numerator of the second fraction, or denominator of the second fraction? 5x to 10x squared, that's multiplied by 2x. So 7 multiplied by 2x, that's 14x. All right. Now, if I subtract these two things, well, I have 15x, take away 14x on the numerator. And that's all over a denominator of 10x squared. That stays the same. Okay. So now what that's left to do is collect together any like terms on the numerator. Well, 15x, take away 14x, that's just going to give me x. So I have x over 10x squared. Okay. And then I can actually make a simplification here, because have a look, if I have x and I'm dividing by x squared, then I've basically cancelled off an x, okay? Because x divided by x squared, I've got one of the x's in the x squared, which I've cancelled off. X divided by x makes 1. So in other words, the final answer is going to be 1 over 10x. Okay, 1 over 10x. All right, fine. Now let's have a go at something a little bit more complicated. Let's try something like this. This is question 5. Let's try 5 over t plus 1 plus 4 over t minus 3. Okay, so here I want the same denominator. They're not the same. So in order to get the same denominator, remember, all I need to do is just multiply these two denominators together. So I just need to multiply these two denominators together. So if I multiply the two denominators together, I get t plus 1 multiplied by t minus 3. I'm just going to write that using brackets. Like so. And I need the same denominator on both fractions. Like so. So I just get the same denominator. I'm just going to write it as two big brackets being multiplied together. Okay. Now, all I need to do is just think, right, what have I multiplied this first fraction by in order to get a t plus 1 times t minus 3 on the denominator? The clue's there. It's right in front of you. I've multiplied by t minus 3. Okay. So I'm just going to write that. I have 5, and I'm going to multiply that by t minus 3, like so. Okay. Same thing with the second fraction. What have I multiplied by to get t plus 1 times t minus 3 on the denominator? Well, we did it right at the very start. I just multiplied by the t plus 1. Okay, so in other words, I get the 4 multiplied by the t minus 1, t plus 1, sorry, on the numerator of that second fraction. Okay, so again, I'm just using brackets. Now I can just write this as a single fraction. So I have t plus 1 multiplied by t minus 3 on the denominator of the fraction. So collect together the denominators, then just simply add together these two numerators. Now all I'm going to do now is just expand out the numerator. So I'm going to expand out first of all the first bracket. So I get 5t minus 15. And then if I expand out the second bracket, I get 4t plus 4. You notice it's positive because it's got positive 4t. Positive 4 times positive t makes positive 4t. Okay, and denominator is t plus 1, t minus 3. All right, okay. Now I just collect together like terms. Well, I have 5t plus 4t. That makes 9t. Negative 15 plus 4 is, what's that? Negative 11. Okay. And then t plus 1 times by t minus 3. Okay. That would be it fully simplified. That would be it fully simplified. All right. Let's try one more and then we will finish off. Okay. So I think this is question 6. Similar kind of idea. Right. Similar kind of idea. So we're going to have y over y minus 2 subtract y over y minus 3. So again, I need the same denominator on both fractions. So I'm just going to multiply these two denominators together. So in other words, get y minus 2 times by y minus 3 on the denominator of both of these fractions. Okay, fine. Now, what have I multiplied the first fraction by in order to get a y minus 2, y minus 3 on the denominator? Multiplied by y minus 3. So in other words, I take the y, which I originally had, and I multiply that by y minus 3. All right. Now, let's have a look at the second fraction. Well, okay, what have I multiplied by to get y minus 2, y minus 3 on the denominator? I've multiplied by y minus 2. Okay, so I take my original y and multiply that by y minus 2. Okay, fine. Now, I'm just going to write this as one big fraction. So the same denominator, y minus 2, y minus 3. And on the numerator, well, I have y times by y minus 3, subtract y times by y minus 2. So let's expand each of these two brackets. So I have y times by y minus 3. That is going to give me y squared minus 3y. Okay, same denominator. Like so. Now this is where I've got to be careful, because you notice it's not just y times by y minus 2. Okay, look at the sign of this second term. It's negative, right? Which means I need to take negative y, and expand it out. Okay, so negative y times by positive y is negative y squared. Then if I take negative y multiplied by negative 2y, that's going to be positive 2y, because a negative times a negative makes a positive. Okay, now I can simplify. Now I can collect together my like terms. Okay, so if I multiply together my like terms now, I get y squared take away y squared, well that's going to be 0, then negative 3y plus 2y, that's going to give me negative y. So I get negative y times by y minus 2, y minus 3. And that would be it fully simplified. So just watch where you've got negatives going on. That's all we need to think about there. And by the way, I've gone through addition and subtraction. The same kind of principle will apply with multiplication, division. You understand what's happening with ordinary fractions, then you can understand what would be happening with algebraic fractions as well. Okay, so just for one final piece of homework then, so this is something that I need you to do, is sort of the weekly task. So as part of these pre-recorded lectures, you need to go away and actually do something as a result of these pre-recorded lectures. Could you have a go at simplifying this for me? Okay, so this is the weekly task. Could you have a go at simplifying this for me? Let's try 3y over y plus 6 minus 2y over y minus 3. Okay, could you simplify this for me? And could you bring it along to your next lesson where your teacher will check that you have done this? Okay, so 3y over y plus 6 minus 2y over y minus 3. Bring that along to your next lesson and then your teacher will check that you've done this. Thank you.